Have you ever wanted to be a Rockstar developer?
Yeah, who wouldn't?
Well, it's actually quite easy. As long as the programming language that you're using is called Rockstar. Rockstar is an esoteric programming language that was developed by Dylan Beattie. It was originally created to confuse job recruiters, since if there was a programming language called Rockstar, anyone who could write anything in it at all could claim to be a, quote, Rockstar developer. Rockstar's code, though, is designed to resemble the lyrics to an 80s rock song. Take the Hello World program, for example. To print a string to the screen, you say shout, followed by the string. The words say and scream also print text to the screen. So, shout hello world will print hello world to the screen. Hold on, quotation marks in a rock song? That doesn't seem very natural. Well, we can write a more poetic version of this program by using variables. There are 3 kinds of variables in Rockstar. Simple variables contain only lowercase letters. Common variables start with one of these words, followed by a space and then the variable name. Finally, proper variables must start with uppercase letters, and they can include spaces.
So, what's the difference between all of these variable types?
Nothing! So in this program, Obfuscate is a proper variable. The line Obfuscate says, hello world, will take the string following says, which in this case is hello world, and stores it in the proper variable named Obfuscate. The line shout Obfuscate will now print Obfuscate's value, which is hello world. So now we have a much less forced-seeming hello world program. What do you think, Obfuscate? I like it! It's like a regular Hello World program, only slightly obfuscated through the form of a rock song. Anyway, variables can also be given number values using a line like, Tux is in Antarctica.
Hold on, so I understand that Tux is the name of the proper variable, but what does in Antarctica do?
Well, in has 2 letters, and Antarctica has 10 letters. If we take the 2 digits in the ones place and concatenate them, we get 20. Therefore, Tux now contains the value of 20. This is a really weird way to store variables, but it's poetic, I guess. Similarly, Neluge is unavailable assigns Neluge's value in a similar way. Unavailable has 11 letters, so Neluge has the value of 1. Aspel is also assigned the value of 1. Up next, this program enters a while loop, which will run while Aspel ain't mysterious. Mysterious is the Rockstar version of null, since null isn't very rock and rolly. While this loop is taking place, Tux will be shouted, and Tux will have his variable changed. The line, let Tux be Neluge with Tux, will set Tux's value to Neluge with Tux. With is just a Rockstar alias for plus, and since we assigned 1 to Neluge earlier, this increments Tux by 1. So this program increments by 1 starting at 20. Now, this program's kinda basic, so here's a more involved one that's similar, but prints something else. This time it's about Hev.
Hev is apioformic. Bees are imaginative. The apioforms are unconfirmed. Let Hev be Hev with the apioforms. While the apioforms ain't mysterious, shout Hev. Let Hev be bees plus the apioforms. Let bees be the apioforms. Let the apioforms be Hev.
This program is similar to that counting program, but it prints the Fibonacci sequence. Bees and the apioforms are set to 1, while Hev is set to 0 and then incremented. So basically, Hev is just set to 1. While the apioforms has a value, aka literally all the time, Hev is shouted, and Hev is set to bees plus the apioforms. Bees are set to the apioforms, and the apioforms are set to Hev. That sounded like nonsense. But it's basically the same as this much nicer code written in C. So, that's nice, but I want to make an interactive program. No offense, but those ones are all kinda lame since the user can't interact with them. Well, here's an interactive program. Tux1, hit it!
The truth machine is never gonna lie. Listen to the truth machine. Your falsehoods aren't puzzling. Well, the truth machine ain't your falsehoods. Shout the truth machine. Scream your falsehoods.
The truth machine is a popular program that takes an input as either 1 or 0. If it's a 1, it outputs 1 indefinitely, and if the input's a 0, it outputs 0 and halts. Why am I saying this? I made a video that's just about this already. But anyway, this program first defines the common variable called the truth machine, without a space because of the rules for common variables. The line "listen to the truth machine" will take in one line of input from the user and store it into the truth machine. Variables in Rockstar are dynamically typed, so if you input a number, the truth machine variable will hold a number. The common variable your falsehoods, meanwhile, contains the value 0. While the truth machine isn't 0, meaning you typed a 1, it prints the variable contained in the truth machine infinitely. Otherwise, it prints a single 0. So, we have a working truth machine program. So here's one final program that combines everything from the previous ones. The calculator. The variables creaturey, Carl, and obfuscate are taken in as input. Carl and creaturey are the values that you're doing the calculation on, and obfuscate is the operation. They are rounded up and down respectively using turn up and turn down. This isn't necessary, but I wanted this specifically to be an integer calculator, and I have no clue why.
Well, that just makes the calculator worse, you idiot!
Excuse me? The term you're looking for is obfuscated. And the term you guys are looking for is go away. Anyway, up next, IDEX is declared and given the value 42, since goin has 4 letters and in has 2 letters. 42 represents the ASCII value for the asterisk, so this operation is multiplication.
Hold on. The user inputted an asterisk, which is clearly a string, but I'm holding a number. How do we compare these?
Using another variable as a middleman. Ctail is declared at the start using the poetic string format, which means that Ctail at the beginning contains the value not to do that. It doesn't really matter though, because we don't even use that value. We then cast IDEX to Ctail, so Ctail now contains the character corresponding to IDEX's ASCII code. This is because Ctail is stored as a string, so the cast turns that number into a string. Finally, if Ctail and obfuscate are holding the same character, meaning the user inputted an asterisk as the operation, the variable esolangs is set to the product of our 2 inputs, and it is printed. Similar structures are used for addition, subtraction, and division. Putting them all together, we get a nice little calculator program that can only do the 4 basic operations. Anyway, thanks for watching, and I'll see you next time!